The first one, how human brain works. This artificial neural network is actually inspired from biological neural networks. Okay, how artificial neural network is actually inspired by biological neural networks. In short, biological neural network is actually our brains. Someone go and study how our brain works and copy the architecture and put inside as artificial neural networks. Okay, so in order to have a better understanding what is RANN, so we have to understand first how our human brain works. So secondly, we will further explore the smallest unit of artificial neural networks. So artificial neural network is actually formed by a lot of neurons. We have a lot of neurons. So we would like to break down this neuron and we just study one neurons. What is the component inside these neurons, and then what are the functions of each of the components inside one neurons. And then lastly, we will combine the neuron to build multi-layer neural networks. You will learn how to draw the architecture for multi-layer neural networks. Okay? So this is I think the big pictures of what is machine learning, what is neural networks, what is deep learning. So AI is, as I mentioned, is any applications that having human behavior. Machine learning is just a technique to achieve the AI, but using the data, a lot of data, and some algorithm to find the relationship. Neural network is a subset to the machine learning. And lastly, we have a deep learning, is another subset to the neural networks. So what is the brain? I believe everyone here, you have brain, right? No. What is inside? Empty. Alamak. Why you're so negative one? You got brain, no? You are here, your ISW are very smart students. ISW is a very smart students. Based on my experience. Okay? So, brains, what is the purpose for brain? To fill up the water, huh? What? To think, to analyze, to reason, to make a decisions, right? To analyze. So human brain is actually formed by you can see the 100 billions of neurons. So what is the neurons? I'm going to show you later. So it's actually formed by 100 billions of neurons and connected together by synapse. Okay? So biological neural network, also known as the brains, are actually formed by neurons. You have a lot of neurons. So you have a neurons connect to another neurons, connect to another neuron. And each neuron here consists of 4 components. Okay, so we are talking about biological neural networks, your brains. Okay, so how the biological neural network works? So firstly, we have some dendrites. So this is called dendrites. Some bio. So maybe you are a bit blur. Okay, dendrites acts as the input to receive information. Whenever we see something, we read something, we receive the information. So we receive from the dendrites. Okay, so all these are dendrites. Okay, so this information will pass through a nucleus. So this is nucleus. UES, nucleus. Okay, or sometimes we call it as soma. So this nucleus is used to process these informations. So this is the information. So we have a lot of information to go through the nucleus. The nucleus will process all the information that we receive from the dendrites. Okay, so after we process the input, we will generate output. So in BNN, the output we call as axon. It's not the acorn axon, AXON, axon. Okay, so receive this process through the nucleus and generate this output. Okay, so once you generate this output, maybe this output could be your final decisions, or maybe it can be used as the input for another neuron. Remember, come back to here. So here we have a nucleus, we process the input, we generate the output. So maybe the output will now become the input to go through another nucleus to further process the input. So maybe at this moment, this output will treat as the input and will pass through another neuron. Okay, so this information here will pass to another neuron and to further process, and then to come out. Okay, so in order to make this thing happen, to pass this information, we need one chemical substance called synapse. So we need this chemical instant here to create a potential difference between this and this, so that this information can pass from one neuron to another neuron. Okay, so we have four components in biological neural networks. The first one is the dendrite, receive the information, process this information using nucleus. After process, then we generate some output through axon. So this axon maybe can treat it as the input, so that this input will pass to another nucleus to process. So in order to make this thing happen, we need this chemical, the last component here, synapse, to pass the information. To further process, we have a dendrite here again. Repeat. So we have a nucleus, axon, okay, pass to another nucleus again. Okay, so just like if I ask you what to eat now, so maybe you have some information, or depends on your mood is bad. Maybe you are not that hungry. Okay, you have some information. So based on these factors, maybe you don't want to eat some heavy food. Your decision here, you do not want to have a heavy meal. So this is not the final decision. You have to pass this information to here again. So you can base on others and maybe environment, maybe other factors, come out again, generate some output. Maybe finally you want to eat what? Maybe just eat some snack. So that's the overall idea. We have to process the information. So this information could maybe not the final decision. So this information will pass to another neuron to further process. Repeat. Okay, so that's why you'll see that in our brain is actually more than 100 billions of neurons. They're actually working in daily, and they're connected by this synapse. Okay, so this is the function for each of these components. We have a soma. Okay, soma is the basic cell bodies to process process the information. Then we have a dendrite used to receive the information. So we have a nucleus to process, after that to generate some output and propagate this output through the axon. So axon here will pass to another neuron, repeat again. So in order to pass the information from one neuron to another neuron, we need this chemical substance called synapse. Okay, so if you look carefully, this is it? It's not working. It's okay. So this is how the brain works. The moment that you think, so there's actually some sparkling. So remember, as I mentioned, in order to pass the information from one neuron to another, so we have this chemical substance to create the potential difference or electrical impulse. So when the electrical impulse occurs, then you have see some lightning inside your brains. Okay, so the more you think, then the more lightning in your brains. So do you know that our brains have two sides? Yeah, left side for what? Our brain have two sides. Yes, our brain have two sides. Left hand side is for art. I think left side is for logical thinking, for
language.
Logic, huh?
Or what we are, what we speak, what we do.
Yeah, analytics, logical thinking. Right hand side meanwhile is for creativity and for
what we feel.
Artistic, emotion. Yeah, what you think, emotion. I think female you are more towards, your right brain is more active lah. For the male, maybe your left brain is more active. Because left brain is more about logical thinking, about analytics. Girls quite emotion, right? So that's why your right brain is more active. Okay. So we can actually copy these ideas exactly the same inside AI. Okay. So this is how it looks like. So the above picture shows the artificial neural networks, and the below one shows the biological neural networks. Okay, so we see how the artificial neural network works. So let's say now we have the input. Okay, so this input is act like the dendrites, right? We have an input here. So assume that this is the input lah. Now we have an output. So this output we will treat as the input. Okay, so we start from here. So we have this input here. So this input will pass to another neuron. Let's say we have the input pass to another neuron. We have another neurons here. So in order to pass the information to another neuron, we have to go through synapse. The synapse in artificial neural networks is known as weight. Okay, or W. So there will be a lot of W lah. Assume that this is one neuron passed to another nucleus. So you have a W2, you have W3. So this one also passed to here, this one also passed to here, this one also passed to here. You have W4, W5, W6. So we have an input, seems like the dendrites. So we have the weight acts like the synapse. Okay, so we have these neurons or the nucleus acts like the processing units. And then finally, we will generate some output. Let's say this way. Let's say now you have another neuron. We will repeat. We pass to here, we pass to here. In order to pass, we have the weight here. So we have a lot of weight. And finally, generate some result. Or maybe this is action. Or the output. In neural network, it's called output, but in biological neural network, it's called action. So this is how artificial neural networks, and this is how biological neural network works. So they are exactly the same. So we have the input. So in order to pass this input to another neuron, so we have to go through the synapse. In neural network, we call as a weight. So we pass through this to process to give you some output, or also known as action in biological neural networks. Okay. So remember, we have 4 components in the biological neural network: dendrite, axon, nucleus, and synapse. In artificial neural network, same. We have input, we have the weight, we have what else? The nucleus. Okay, so this is the nucleus, or the nucleus. And then last one is the output. 4 components. Each component play its own roles. Input go through the nucleus to process the information, and to generate the output is called axon. So axon, to pass through another neuron, we need synapse, or in neural network we call as weight. Okay? Is that clear? Okay, good. So this is the comparison between the BAN and ANN. So their function is about the same. Soma, neurons, dendrites, input, axon, output, synapse, and weight. So allow me to spend some time to explain to you what is weight. Okay, so weight in biological neural networks is used to pass the information from one neuron to another neuron. But in neural networks, there is some functions or called weight. So this weight here is used to show or to express the strength or the importance of the neuron input. It shows how important of your input. Assuming that you would like to predict the disease, some disease based on the patient's maybe patient symptoms. Okay, so let's say now you have one input. So this is your input 1, x1. It's called symptom. So you have another neuron, so-called the second features, SYPT here. Okay, second features, maybe their weight. You have third features, it's called patient ID. Okay, I don't know how to put weight lah, confused. Maybe height. Okay, So remember, each of this input here you perform, you have what? You have W. You have W. You have W. So forget about what is happening inside here. So this actually performs some calculations. So the process, we actually assume that this is nucleus. So we have an input, we go into the nucleus and perform the calculations. Okay, so this W1, W2, W3 initially will be a random assigned value. Let's say 0.5. 0.5. Let's say all equally assigned 0.5. So when we go into these calculations, we perform the calculations here, it will generate some predicted y. Okay, so I'm going to show you how the complete process, how neural network works. Assuming that we want to identify, I would like to explain to you what is W first. Okay, so assume that we have a X, we have a X, we have a X, we have a W1, W2, W3, and I randomly assign this W as 0.5, 0.5, 0.5. And then we will pass this information into this nucleus to perform some calculations. Once you perform the calculations, we will generate some predicted Y. So this predicted Y will compare to the actual Y, so that we can get some error value here. Okay, you have a predicted Y, you have an actual Y, you can calculate the errors. What is the purpose for these errors? These errors will then feed back here to adjust this weight. If your features play very important roles in these so-called predictions, then you will notice that this W, the value W here, will increase. It shows this features is important. Logically, do you think symptoms play very important roles to predict a disease? Yes. You will notice that the moment we get the error, we feed back here, so it will adjust this 0.5, slowly increase maybe to 0.7. Do you think the height is very important to predict a disease? No. Maybe yes, maybe no, not that significant. Okay, so maybe it will maintain. Do you think patient IDs is a very important feature to train the models? No. So you will notice that the moment I feed back this error to here, it will adjust. Maybe it reduce to 0.1. So you know what is the meaning of W? Wait, it shows how important of these neurons inputs. Okay? The moment that we train, if these features is important, then you will get the very high value of weight. If the neuron, this patient ID, this features is not important, you will get this W getting reducing. The value is reduced. Okay? So that's the reason I say, come back to here. Machine learning, we need to manually select which X is very important. But neural networks, you don't need. Because during the training process, if this features is important, it will automatically adjust the weight to higher value. If features is not important, this process will reduce the weight for this particular input if this input is not significant. Okay? Clear? Alright. Then, if clear, we go into the smallest units of neural networks. You still remember neural networks is formed by billions of neurons connected by the synapse. So we just break it down into one unit. Let's see how these neurons is going to calculate and find out the errors. It's okay. So anyone would like to help me to clean the whiteboard? Blender is not free now. Anyone? Oh, thank you. So do you want this? The one that I clean? Thank you. This one, I'll clean this one. And also this one. I'll clean all now. Thank you. I'm calling you. Help me to clean. It's okay, it's okay. We got another helper. take your attendance. Okay, thank you very much. Bonus. Next semester.
Next semester.
Okay, so if we break down these neural networks, the smallest units of neural networks is called, in the artificial neural network, is called perceptron. So don't get confused. Perceptron is actually referred to a single unit of neurons. Remember, you have a lot of neurons here. Okay, you connect to each other, right? You will process. So we just take this one neuron. It's called perceptron. It's just terms, it's just a term called perceptron. So these perceptrons is actually developed by this guy called Frank Rosenberg in the 1958. It consists of 4 components, a single neuron. Okay, so this is a perceptron. We have a single neuron here. So you will see this icon is called summations. Linear combiner. Sometimes it's called summations or linear combiner. Okay, so you have a neuron here, which is called linear combiner. We have adjustable synaptic weight. Assume that you have 2 inputs, you have 1 weight, and you have 2 weights here. So we have to assign the weight for each of these inputs. So we have this input x1, input x2. So this linear combiner will perform this x1 and w1 to do a calculations to generate a value. To generate this value, and this value will compare with this hard limiter. It's called activation functions. I'm going to show you several types of activation function. What is the purpose for these activation functions? Normally, this activation function will come together with a threshold value. So don't worry, the threshold value comes together with the activation function. It will adjust automatically. Okay. So this activation function is the purpose is to adjust or to activate whether we have this value. We want to activate whether this value is considered true or false. Okay. Or in this case, we would like to use this activation function to perform the classifications. I'm going to show you later. And lastly, we used to produce a predicted one. Okay, so this is the components inside a perceptron. We have a neurons to perform the calculations. We have the weight corresponding to each of these inputs. We have an activation functions come together with the threshold value and used to predict a y value. Okay. So now let's see how this perceptron works. Step 1. Normally we will randomly assign the W1 and W2 randomly. For example, in this case, I adjust to 0.5. Randomly adjust. Assign 0.5. In the first round of training. We don't know what is the W1 and W2. We just randomly assign, as well as the threshold values. Normally in the program, you do not need to set. It will set for you by default. Okay. And then we will insert this x1 W1 and x2 W2 inside these linear combiners using these equations. We just multiply them together. Okay, means that your x1, you have the value, multiply with this value, plus this x2 with this 0.5. Bear in mind, if your input is in categorical data, for example, female, male, tall, short, then you have to convert into a number, a numerical value, 0 to 1, because we need to perform calculation inside these neurons. So you cannot have any string here. You must convert into a value. Okay? So we have this value multiplied with this W1. We have this value multiplied with this W2. At this moment, I don't want to assign any value, confused. So this linear combiner will just add these two so-called parameters, x1 multiplied w1 plus x2 multiplied w2. So by add up these two terms here, it will give you some value. Okay, it will give you this value. Okay, so this value will then send into these activation functions. For your information, in this perceptron, the activation function that we use here is called step functions. But there are a lot of functions that are available in the market. So you will see they have a step function, sine function, sigmoid function, linear functions. Nowadays we have one famous one. Normally we use value functions for convolutional neural networks. We have a CNN, we have a RCNN, we have a RNN. So they are about the same. Okay, the way they perform is about the same, but the activation function that you use now is called value functions. So, but for the perceptrons, the function that we use is called step functions. So, how to interpret these step functions? Yeah. Are you able to see this icon? Cannot also. Can. If you look at your slide, it should be something like this. Y step equal to 1 if x more or equal to 0, 0 if x less than 0. Correct? Good. It means what? It means that after we perform, we get this value here from this linear combiner. We have to send it back to these activation functions to compare. If this value here, which is the big X, more or equal to 0. If more or equal to 0, then we will classify this value as 1. If the value that you get here is less than 0, then we are going to classify this data as 0. You just treat at this moment 1 may be a female, maybe 0 as male. So it means that if the value that you generate here is more than or equal to 0, then we classify to 1. If less than 0, then we classify to 0. Okay, the purpose of this activation function is to do the classification for this case. By using the RNN, CNN here, then we use it for different purpose. Okay, so in this case, we assume that the threshold value is equal to 0. Okay, we assume, but most of the times you will have this threshold value. Normally it will be given. If let's say the threshold value now we set equal to 0.4. What is this threshold value? It's as a line to adjust your decision boundary. Okay, so if let's say in this case threshold is equal to 0.2, then we have to modify a little bit on these equations. So this one will become more than this threshold. This is less than this threshold. Okay, so we can bring this threshold to the left hand side so that we can have a better understanding or simplify our calculation later. So if we adjust, move this threshold value to this left hand side, then you have this x plus, if this value is a positive value, then you have this minus threshold value. So 0 if x plus is the same. They are the same. Just we bring the threshold value to the left hand side. Okay, but if you bring this threshold to the left hand side, we won't call this as a threshold anymore. We will call it as bias. But they are the same. They are the same. But I just worry that sometimes you go across the Google, sometimes you give you a threshold value, sometimes it give you a bias value. They are refer to the same thing. Okay, threshold we bring to the left hand side is called bias. So in this case, if the threshold value is 0.2, then you just minus 0.2. In other words, you would like to get this value from x1, w1, x2, w2 minus the threshold value and compare to this activation functions. Compared to this activation function, these ones will be your predicted output. Okay. So don't worry. Later I'm going to show you one a simple example. Then you will see the overall process flow. So this is just a theory. Okay. So once we calculate the predicted output here, we get the predicted y. We are going to compare with the actual y. So when we compare the predicted y and actual y, so that we will get some errors here. So what is the purpose for error? What's the purpose for errors? No, we need this error to send it back to here and adjust your W1 and W2. So remember, just now I says, what is W1 and W2 to show how importance of one features. If this features is important, eventually you will get a very high value of weight. So how to adjust based on the errors here. For the step functions, we use errors. But for the other type of function, for example, value functions, then we have to use a gradient descent. It's another technique. Okay, so this error will send it back to here and adjust the weight using this equation. Yeah. I'll try to recall what is the equations for this. It should be WIP plus 1 equal to W1P plus what is this symbol? Huh? Delta. Delta is what? This one. Triangle. Oh, this. Okay. W1P. So these terms is referred to the below ones, which is equal to alpha multiply x1P multiply errors at this P. Okay, so I'm going to show you how to substitute the value. No need to worry about this equation. No need to memorize. You will just substitute. So once you substitute, you will get a new weight. A new weight here. Then you repeat the same things. Repeat until you get the consistent W1 and W2. Okay, so before we go to the examples, we take a rest first for 10 minutes. Okay, and then come back, we try these questions. Okay.
现在休息。
你们等一下是回家还是只继续在这里？
应该继续。
灰灰，特别。
他这样是啥？我不知道是什么。
什么来着？
炸冰淇淋。
哦，炸冰淇淋
在哪里买？
哪里买？
就那条走廊那里啊，
哦
那个去躲避那里，
哦，
3块半。
那个广场那边就
它有各种哎，不对不对，这有什么肉呀？
应该是不可及的市场。
Indonesia? Toilet. Okay. Okay, welcome back. Are you still with me? You want to sleep, then continue lah. Okay, so come back to here first at the errors. How do we calculate the errors? So we're going to use these equations, and this alpha is actually referred to the learning rate. So it's referred to how fast that you want the machine to learn. If you want the machine to learn very quick, then you set a very high value. If you want the machine to learn slowly, you set very low. Normally the default value will be 0.1. Normally 0.1. So we don't disturb it. We set it for default value. So, but if you set high value, means that the machine will learn very fast. Probably the accuracy is not that high. If you set the learning rate is very low, means that the machine will learn very slow, but it probably take a lot of time. Okay, so come back to these questions. So assuming that you have this actual data set, okay, so you have a 4 data set here, x1, x2, and the output. I will assume that maybe x1 is whether you're having a sweet smile or not. Okay. If 1 means sweet, 0 means not sweet. Maybe x2 is about your hair length. Hair length. Okay, so 0 is short, 1 is long, for example. And 0 maybe is I will send it for a male. Maybe 1 is a female. Okay, so we have this. We have the 2 features used to generate the output here. So how to start? So epoch 1 means that the first round of trainings. The first round of trainings. So for first round of trainings, we will take only the first data first. Okay. So we will take the first set of data and put it here. 0, 0. The actual output is 0. What is the initial weight? In this case, for the first round, we will randomly assign. So in this case, 0.3, negative 0.1 is it? Randomly assign. You cannot control. We just randomly assign 0.3, negative 0.1, any value. Between negative 0.5 to 0.5, randomly assign. So what we'll do here is we will take this value 0, 0. So this is 0.3. We have 0. We have negative 0.1. So we use this 0 multiply 0.3 plus 0 multiply negative 0.1. Okay, so 0 multiply 0.3 plus 0 multiply negative 0.1. You get what? You get 0, right? You get 0. This 0 is not the output, but this 0 is the value that generated from this linear combiner. Okay, then we have to compare with this threshold value. So the threshold value is given as 0.2. So this is 0.2. So this is 0.2. Okay, the threshold value will be given. The threshold value in the question stated 0.2. So my question is, you get this value which is 0. 0, is it more than or equal 0.2 or less than 0.2? Less than 0.2. If this value is less than 0.2, we assign this value of the output as 0. It means that your predicted result will be equal to 0. Okay, so we will come back to here. Your predicted value will be 0. Okay, you have the actual, you have the predict. We use the actual minus the predict. Actual minus the predict, you will get 0. Okay, so we have this error 0 here. We substitute to get equations. Okay, so it's the equations. Too small. W1. Okay, W1 plus alpha multiply x1 multiply the errors. Okay, so we will update these two values. Okay, so we go through we calculate W one by one. W1 first and then W2. So what is W1? Originally is 0.3. Learning rate is given 0.1. It's a constant. Multiply the x1 0. Multiply the errors that you get here, you get 0. So eventually you will get 0.3 plus 0, right? You get back what? 0.3. So this one will be your new weight for input 1, the first input. Find the W2. W2 plus learning x2 multiply errors, which is equal to W2, you will get negative 0.1, the original, plus learning rate, multiply the x2 0, multiply the errors 0. You will get negative 0.1 plus 0, which is negative 0.1. So this is your latest, the new weight here. It means that after we run this linear combiners, we compare the answer, we get the actuals predicted, we compare to the actual, we get the errors here, we feed back to here and adjust this weight. Adjust this weight. So after you adjust, you get back the same for this round of trainings, which is 0.3 and negative 0.1. Okay, so this 0.3 and negative 0.1 will bring it down to the second set of data. Bring it down here, 0.3, negative 1, and to run for the second set of data, 0, 1, 0, 1, 0. Then you repeat for the same process. This multiply this plus this multiply this, compare the threshold value, you will get the predicted y. In this case is 0. Okay, 0 minus 0, you will get 0. Repeat, then you will get 0.3, negative 0.1. Bring this new weight to the third set of data. Okay, so the set of data is 1, 0, 0. You this multiply this, okay, let's try this. 1 multiply with 0.3 plus 0 multiply negative 0.1, you get 0.3. Compared to the threshold value, is 0.3 more than or equal to 0.2 or less than 0.2? More. Okay, if more than, we classify to 1 or 0. 1, right? It's more than 0, more than 0.2, right? If you look at these equations, that y is that. So you will get predicted y equal to 1. Okay, so equal to this, this. Okay, so you get 0.3, get 0.3. 0.3, is it more than or equal or less than? More than. If more than, then we classify this data into 1. So that's why your predicted y is equal to 1. So 0 minus 1, you get negative 0.1. So now you get the errors here. Substitute this equation. Then you will get the new weight 0.2, negative 0.1. It reduced from 0.3, 0.3, now it dropped to 0.2. Then we bring it down here, have a 0.2, negative 0.1. So the last data, 1, 1, 1. You repeat. When you repeat, then you will get this is 0, this is 1, then it increase back to 0.3, this one increase to 0.0. Okay? So once you done the whole one set of data, it's called you done one epoch. Then you have to repeat for the second epoch. Okay, you have to repeat for the second epoch, use the same round of data. Okay, start from the beginning, 0, 0, actual 1, 0. This one, bring it down to here, 0.3, 0, and calculate this. Okay, this one, bring it down to here, repeat, second round, epoch, third, fourth, fifth. Yeah. So normally in the neural network, we set hundreds, 100, 200, 500. In practicals next week, later I'm going to show you. By default, we set 500 of epoch. So you can imagine how many rounds that you use to train the models. Train until when? Until. So this one you go and study same. So we have x1 multiply w1, x2 multiply w2, and compared to the threshold value. So we classify whether it's 1 or 0, and then we use the predicted, and then we have the actuals, we get the errors. So and then lastly we update the w1 and w2. Okay. Then we bring it down to the second set of data. Okay, so we will continue to train until when? Until you found out that in any epoch here, you will see that from here 0.3, 0.3, then it dropped to 0.2, means that it's not stable yet. Look at the second epoch, 0.3, 0.3 dropped to 0.2, it's not stable also. Third epoch, 0.2, 0.2 dropped to 0.1 is not stable. 0.2, 0.2 dropped to 0.1 is not stable. And the last epoch here, you see that 0.1 consistent. All consistent, this one also consistent. Then it means that your model is stable, is consistent. Then we will stop at epoch number 5. Although in the program you set epoch 500, but once the final weight is consistent, it will stop it there also. It will not continue to run until 500 epoch. It will stop until when? Until your final weight is consistent or not changing anymore. Not increase, not decrease. Remain the same. Okay, so you can see that initially is 0.3, negative 0.1, but you keep training, eventually this one will drop to 0.1. This one increase to 0.1. So what we can conclude here, we can say that, oh, this x1 is not that important as we think, because eventually it dropped to 0.1. And x2 here is not that, it's quite significant. You can see that from negative 0.1, it increased to 0.1. Okay? So sorry. This one. Use this minus this. So to get errors, actual minus the predict. For the step function, for this case, yes, it's very simple. So we use actual minus predict. But if you use others, let's say you want to build your assignments, RCNN, CNN, the errors is not simply minus the actual with the predict. You have to use this technique, gradient descent, to find the gradient and to get the errors. That will be a bit more complicated. But for this case, step function is very simple. We just use the actual minus the predict, you get the errors. Then you use the errors, substitute into these equations, you will update your weight for the second set of data. Okay, so you see that the overall training process, it involves two phases. The first phase is called feed forward. Okay, it's where we insert this input and the weight to calculate and to predict what is the y value. And then we have a second process from the right hand side back to the left hand side. It's called back propagations. What is the purpose for back propagations? Is to send this error back to here and update your weight 1 and weight 2. Okay, so during the training process, is artificial neural network, it includes two steps. The first step, feed forwarding, and then second step, back propagation. Okay, so once done, you have stabilized your models, then we can use it for prediction purpose. So in this case, if for prediction purpose, then we don't use this one anymore. Okay, so we straight away use this. We already stabilized, right? So we know that this is 0.1, this is 0.1. Then we can use this model to predict. If let's say we have an x1, 1 or 1, we send it and then we just get the predicted value. It's called feed forward. Feed forward is normally used to predict the output. If you feed forward and back propagations, is normally used to train your models. Okay? Oof. Help me. All up. Can no. Want to take picture? It's okay. We have an exercise later. So even in the tutorial, we have a 2 or 3 questions.
我昨天写的字，做那个词，
那写词
重要的话就把它抹掉。
我写的不是名字，我忘记这个是红笔，
为什么？
Okay, thank you.
好像是只中了2块4。
Yeah. So in the market, you probably will see a lot of type of neural networks. So this is the basic one. Is called artificial neural networks lah. The overall idea is why we use the input feed into these models, and each of these model we will assign one weight, and we will multiply this, do some computations, and multiply this weight and the x, and to compare with the activation functions to get you some predicted ones, and then we feed back to the initial ones to adjust the weight. So in the market, you probably see like the convolutional neural networks. So this one is mainly for image processing, image type of applications or object recognition, object detections. We use RNN. Recurrent neural network is mainly for time series data, series or sequential data. It's normally we use it for the NLP or speech recognitions. Okay, so and a lot more you have a RCNN, but the overall idea is about the same. We use to train the models, and we don't care. We don't need to manually select your X. So this neural network will adjust the weight and identify which features is important, which one is not significant. Adjust for you. Okay. But however, it takes a lot of time, as you can see. It takes a lot of time, especially for the CNN image one, because we have to analyze pixel by pixels. So these are the types of neural networks that you can probably see. A single neural network is called perceptron. We have a multi-layer neural networks and so on and so forth. Okay, so if we join these neurons together, so we have a perceptron. So we can actually join to another perceptron. We can join to another perceptron. The more that we join here, the more the models will learn. Okay, right? Just now you see that one neurons that you will process. So if you put more, if you join the more neurons, it means that a lot more calculations is performing inside this neuron. And these, if you join all together, is called multi-layer neural networks. Okay, just a name. You have a single neuron, it's called perceptron. If you join more perceptron in different layers, it's called multi-layer neural networks. So this is the architecture for a multi-layer neural networks, where we have an input layer, x1, x2, x3. So we will send this input into a layer called hidden layer. Hidden layers. So each so-called branch here will have a weight. Remember, each input we are going to assign the weights here, and then after we calculate it, we have some output. So this output we treat as an input and send into another neuron. So this one will probably is the output layer to predict the y, whether it's yes or no. So this one is where we have a one hidden layers. So this is the architecture where we have two hidden layers, right? We have an input, we have a two hidden layers. So we don't really care what is happening inside the hidden layers. What we care is the output. So we want to get the output and compare with the predicted one. So what is happening inside here, we don't care. So as long as this artificial neural networks will automatically adjust the weight for us. Okay. Yeah. So this is a feed-forward neural network. Is mainly to predict the output. So it's not like this. Okay, so this is a feed forward. We have an X, we just feed forward to predict. Okay, so when you see the neural network backpropagations, then this means that you're going to train the models. You're training a model, so you have to feed back some errors to your either hidden layers to adjust the weight for each of the layers. Okay, so the loss here is the errors. To calculate the loss, come back here and adjust the weight. Okay, so that's it. For there are a lot of theory here, so you just go through yourself. It's not very important. As long as you can understand the ideas of the perceptrons and how to draw the multi-layer neural network, then it's okay. Okay, so let's go through some partial questions. Okay, so this is one of the partial questions. A team of researchers aim to predict a diabetes using a multi-layer neural networks. So table 2 shows a dataset that's being used in this research. Designs and architecture means that you have to draw based on the table 2 and label the structures clearly. So how to draw? So you just need to identify how many inputs. So there are 7 inputs here, then you just draw lah. 1, 2, 3, 4, 5, 6, 7. So this is your input layer. So you have to label it. This is input layer. So one is the name. So you have a patient ID, and then you have a blood pressure. So you have to label it properly. Glucose. So you have insulin, BMI, age, and diabetes. Okay. So the question stated design multi-layer neural networks. So multi-layer neural networks means that you must have at least one hidden layer. Okay. Multi-layer neural network means that you must have at least one hidden layers. So you can add more hidden layers as you like. You can put hidden layer 1, hidden layer 2, 3. It's up to you. So inside each hidden layer here, you can design how many neurons that you want. You can set 2, you can set 3, you can set 1. It's up to you. Okay, as I mentioned, the more the neuron that you put, the more calculations it will take and the more time it will consume. So next week in the practical problem, I will show you how the effects if we increase the hidden layers, we increase more neurons. The result is more accurate, but somehow it takes more time. Okay, and then maybe in this case I will just set one hidden layer. You can add more, and then lastly is the output layer. So what is the output here? 2. So the diabetes is not diabetes is the output. Okay, it's not the input. So yeah, diabetes is your output. You want to predict based on these 6 features whether it so-called has this diabetes or not. So you can set 2 neurons. So this is called yes and no. Diabetes. So this is diabetes. Okay, and then you just join together. Oops. Okay, and then this as well. How many marks? 4 marks. 1, 2, 3, 4. Simple. No? 4 marks. Bonus. But students don't know how to draw. No. Some answer I get from the students, they draw like this. They draw like this. Okay, patient ID. Then they send to blood pressure. Then they send to glucose. And they send to diabetes. Well, this is the common answer I receive from students. This is not true. So always remember, input layer is only for input. Hidden layer is for neuron, and then output layer is for output. This is all input. This is wrong. Okay, Jackson. Okay, so let's move on to the next. Give me some time to take picture first. So don't worry, although we have a patient IDs here, so if you still remember just now, this neural network will adjust the weights. Although we have a weight here, we have a lot of weight here. So eventually you will notice that the patient ID, the weight for the patient IDs will be very low, maybe near to 0. It's not significant. So this neural network will adjust for you. Okay, so let's move on to the next questions. Yeah. Can see or not? Very honest. Okay. So this is one of the tutorial questions. Can you try this? Then we compare your answer. I think I'll piece of paper. Yeah. And yeah, this is the perceptron I showed you earlier on. But you have to look at this question properly. Identify what is the functions that we use. We are using size functions. Earlier on is the step functions. What is step function? Is anything that is more than the threshold value assigned to 1. Less than a threshold value assigned to 0. Size function is anything more than the threshold value, which is the this assigned to 1 less than a threshold value assigned to -1. So that is the sign function stand for. Okay. So we have the threshold value 0.2 given, running rate 0.1 given, W1 and W2 at the first iterations given, then you generate the find out what is the final weight. This one I think you just follow the same the step lah. Okay, I give you 10 minutes 10 minutes.
你不能发现 hidden layer 是一个连续每一个是对的，是不是？
啊，每一个有连一个。
没有看老师有些没有画。
看怎么做。哦，这题
这完了就这样快要手术。
这个我觉得就连线就好了。还要算。
4分吧。
刚才讲这个 hidden layer 是看的是，就要画直的这个东西，为什么？
我刚才会动。
是把这个东西做一遍，
然后做一遍是很长的了，不是？
不仅能做
上面一样的题目。
一样的。
这样做。就写纸上面。 活到变成可以变化，可以变化。
我在好奇，这个 W 是哪里拿到的？
然后做什么？W E 等于 W 加 S 加乘 S 乘 L。
Okay, let's fill in the blank together. Okay, so how to get the predicted y? Don't know. First step, apply this equation. Always remember the structure. x1, x2. You have a w1, w2. You go to this linear combiner first. This is your step 1. This is step 1. Can you multiply? x1 multiply w1, x2 multiply w2. x1 multiply w1, x2 multiply w2. Get 0. 0, you will get 0 here. This is not your output. You have to compare with your activation functions. So this is step 2. So this is step 2. Okay, is your value here, which is the summations, more than or less than 0.2? Why 0.2? Because the threshold value, go back to the equations, is it more or less than? Less than, right? 0 less than 0.2. If 0 less than 0.2, so this is your predicted one, negative 1. So this negative 1 will be your predicted y. Okay, yeah? So step 3. What is the errors? How to find the error? Actual y minus with the predicted y. Negative 1 minus negative 1, how many you get? Negative 2, huh? Negative 1 minus negative 1, you will get negative 1 plus 1. Negative 1 plus negative 1, you get negative 2. So once you get this wrong, then you have all the iteration data you get wrong. Errors, 0. Okay, so you get these errors. What is the purpose for the errors? So we want to feed back to here to adjust this W1 and W2, which is step number 4. So you have to use this step 4 here. Okay, I'm going to show you how to update the W1, which is equal to the O weight, which is the O weight, which is 0.1, plus the learning rate is given is 0.1, multiply the input. What is your input? 0. Multiply your errors. Your errors also 0. So you will get 0.1 plus 0. You will get 0.1. So this is your new weight here. Repeat for W2. Okay, repeat for W2. W2 is 0.2. plus learning rate multiply the input multiply the errors, you get 0.2. This is 0.2. Bring these two value into here. And repeat, yeah. Let me check with the answer. I'm not confident also. At least complete this one so that this is one of the question in the tutorial. So we can settle this one, then yeah, we can settle one question from tutorial. Then you can go back early. Giving your tutorial 0.1, 0.2, yes, correct. So you repeat for the second data, third, and fourth lah.
然后 W 怎么说？
W 你就用那个 W
这是我字啊。W O
WI 加
Repeat, repeat for second data, then you settle for this and this Okay.
W
Come back to
加
here,
W
reset again, start over from the step 1. X1 multiply this plus this multiply this, you get what? This multiply this plus this multiply this. What value? 0 point. This multiply this, you get 0. Plus 1 multiply 0.2. 0.2. 0.2 compare, go to the step 2. Is it more or equal to that 0.2 or less than 0.2? More or equal. If this fulfill, then your predicted output will be 1. Your predicted output will be 1.
W 等于 WO 加
So how to get the errors?
乘 X
Actual y minus
这是 W
predicted y. 0.
WO W
Update again your W1 and W2. I think W1 and W2 you will get back the same value. Okay, you substitute this, you get back the same value. Bring this 0.1, 0.2 to the third data. Ah,
就是 W O 加这个 alpha 乘 X 乘 L。
啊，要发0.1，哦0.1
题目，
啊，
然后这边0.2来干嘛？
0.2，0.2我不确定，没有看到红的。
微送，加送，发送，微送。
0.2是否认的？
The value for this
哦，这是0.1。
1. Someone say 1.
Negative 1.
Negative 1 or 1?
Negative 1.
Negative 1. So this 1 minus negative 1, you get what? 2 confirm 1 minus negative 1, 1 plus 1, 2 that's it next one. Okay, so you have to, you update the value. What is this value?
乘 X 乘 L。
啊，乘
乘对应。
So you have x1, w1, 0.1 plus the learning rate multiply the x1 multiply with the errors. So you get 0.1 plus 0.2. So you get 0.3. This one is 0.3. How about the second one? 0.2. 2. So bring it down to here. 0.3, 0.2. What is the value? 1. So what's the value here? 1 minus 1, you will get 0. So you get 0.3, 0.2. Yeah, so that will be the final W1 and W2 for the only first epoch. And you can see that this is not consistent yet. 0.101 increase to 0.3. So by right, you have to repeat for second impulse, third impulse until you get the consistent weight 1 and weight 2. But theoretically, so this is how it works, but impossible when we go and calculate. So we let the machine to do the task for us. We let the machine to calculate to find the stable the weight 1 and weight 2. Okay, yeah. That's it for today. Yeah. So remember, so this neural network is a subset to machine learning. It performs the same like the machine learning. What is the purpose? Make decisions, make predictions. But the only difference here is we do not need to manually select which X1, X2 are important. We let the machine to adjust the weight for us. Okay, so no questions. Thank you. Remember next week, next Monday, midterm test. Okay, 6:30 to 8. 6:30 to 8. So if you miss the midterm test without any reason, then you will score 0. If you are sick, you have an urgent, then you have to apply letter from the office. You need to prove to me, then only you are entitled for so-called another round of midterm test. Otherwise, I consider you absent. Okay, so no questions. That's all for today. Enjoy your long weekends for those who are not coming to school on the Friday. Yeah, happy holiday. Selamat Merdeka.
你凌晨0一定是0啊，
我在后面的一起说。
先清楚一点。
所以下个星期一个考试。没有3个，这样还哦，那个是那个不是。那你3个星期？Week 11。